Why Greenhouse Gases Trap Heat in Our Atmosphere, a short film by Amy Eisenberg. So, here's the Earth. We like it here. It's a nice place to live. But our Earth's not all alone. It's got an atmosphere between us and space. That atmosphere is made up of lots of molecules of different gases. And of course, we're not alone in space. We've got the sun to give us energy. The sun sends lots of energy our way in the form of electromagnetic radiation. Some of it's really intense stuff, like gamma rays and X-rays and ultraviolet rays. Some of the rays from the sun bounce right off our atmosphere without really changing. They're reflected, like in a mirror. Others might be absorbed by our atmosphere before they can hit the Earth. You've probably heard of the ozone layer. O3, or ozone, is a gas high up in our atmosphere. Molecules like ozone vibrate at a particular rate. Because of the rules of quantum mechanics, they can interact with only certain wavelengths of electromagnetic radiation. For ozone, ultraviolet light is just the right wavelength to amplify its oscillation. Eventually, this will give off heat, making the ozone layer actually quite warm. Ultraviolet radiation can also split off one of the 3 oxygen atoms to go and find a new oxygen friend, creating O2, what we like to breathe. Either of these scenarios turns the energy from the ultraviolet radiation into more of a heat radiation, infrared. And that's lucky for us, because ultraviolet radiation is really hard on us and gives us things like skin cancer. Now back to Earth. The sun sends us lots of different types of electromagnetic radiation. We get gamma rays and X-rays and ultraviolet rays, waves that we see as visible light, infrared radiation, microwaves, and radio waves. And all of these waves either reflect off our atmosphere, pass directly through our atmosphere, or are absorbed by molecules within our atmosphere based on the properties of those molecules. So let's zoom in a little bit. The electromagnetic radiation that makes it through our atmosphere hasn't really changed. It's still the same wavelength, the same intensity. And it can either reflect off the Earth's surface, especially places like ice-covered polar regions, or it can be absorbed by the Earth's surface, whether that be a landmass or water. Water is especially good at absorbing radiation. And this is when the wavelength changes. Electromagnetic radiation that's been absorbed by the planet will be re-radiated eventually as infrared radiation, something we think of as heat. This wavelength will interact with the molecules in the atmosphere differently than the energy did on its way in. While clouds can reflect electromagnetic radiation on its way into our atmosphere, they can also absorb it, especially infrared radiation. When clouds absorb infrared radiation, most of it cannot escape the atmosphere. Instead, the water molecules in the cloud heat up, and then the heat is re-emitted into the atmosphere, including back towards the Earth. Of course, some of the infrared radiation will escape the atmosphere back out into space. Some of the infrared radiation will interact with carbon dioxide, CO2, where it will also be trapped and then re-emitted as heat back to the Earth and into the atmosphere. Methane is also extremely good at this. But surprisingly, one greenhouse gas that few people think about is actually H2O. Water vapor is actually one of the most effective greenhouse gases and is extremely abundant in our atmosphere. So to recap, our atmosphere is made up of a lot of different molecules, some of which will allow electromagnetic radiation of certain wavelengths to pass straight through, but then will block and absorb infrared radiation when it's re-emitted from the Earth's surface. This chart shows how H2O and carbon dioxide will absorb nearly 100% of certain wavelengths of electromagnetic radiation, but 20% or less of other wavelengths. This explains why an increase in greenhouse gases also results in an increase in global temperature, because the electromagnetic energy can slip in between these peaks but then be trapped by these gases when it's re-emitted as infrared radiation. Remember, like ozone, each of these gases has specific wavelengths that it will absorb the most. Water vapor, for example, is very good at absorbing any infrared radiation at around 12 microns or above. It can do this by either amplifying its oscillation or by increasing its rotation rate. Either way, it will heat up the molecule more, and then that heat will be re-emitted eventually as infrared radiation. It starts to get really serious when you combine molecules in the atmosphere. Remember, it's not made up of just water vapor. So CO2 does the same thing, but it will do this at anything above around 15 microns. Methane, for example, is very potent because it can absorb a very high energy, shorter wavelength, around 4 microns of infrared radiation that the H2O and the carbon dioxide otherwise might not have picked up. So that is going to increase our warming dramatically. Now, greenhouse gases are not all bad. The greenhouse effect on our planet is actually the only reason why any of us can survive here. If we didn't have the greenhouse effect, our planet would be so cold we couldn't make it. In fact, the average global temperature would be about negative 18 Celsius. Our oceans would freeze, we would have no liquid water, and we would just be a dead planet. Instead, because of our greenhouse effect, our current temperature is right around almost 14 degrees Celsius or 57 Fahrenheit as an average. That's a little warmer than it's been in the recent past because of global warming. Really, what we need to worry about is not wiping out the greenhouse effect, but rather making sure that our global energy balance can stay in check so that we do not warm our climate too much with these greenhouse gases.